So in this case, we can look at object in term of programming, right? So I'm going to run the IntelliJ, and we're going to build a user object. Right? We try to show you what's object and how we make an object in programming. So we said we have to make objects from other objects, and we try to make an online banking system, and then online banking system should combine with many objects, right? And we said it's gonna be one is the users, one is the bank account, right? And it could be more. Now we just look at, okay, let's make those two components, right? Then user can register, like log in, register account and log in and be able to access to their banking information, right? So before we create a programming in Java code, we actually relying on a diagram. Just like an engineer, when they build a house or a building, they rely on the blueprint, right? The design. So we are software engineers, so we're relying on a UML diagram. Okay. So let's look at what is UML diagram. It's pretty much just a flowchart or a diagram that represents the system. The one that we specifically want to look at is a class diagram. Class, like we write a program, we start with class, right? In Java, so that represents a class. In this case, can you tell me, I want to build a user object, right? So I'm going to look at the object. This is look like class diagram. Let me, there you go. Sorry, I just zoom in a little bit too much. So class diagrams are the backbone of almost every object-oriented method, including UML. So they describe the static structure of a system. Let's see if they have example. There you go. Remember, we want to do online banking system, right? So let's see what is this example about. So first, we will look at the basic notation of the class diagram. You're going to draw a rectangle that have rows with one column. The first row represents the class name. The second row is going to be attributes. Now, can anyone tell me? Actually, I'm going to use the, you can go to Lucidchart. Now I use Lucidchart. I think there's a free version that you can use to draw the UML diagram. There are many programs that you can use. Okay.
Would you recommend using a program instead of just drawing it out?
Right, I do. Yeah, I do recommending a program. It's just like I recommend to use IntelliJ instead of using Notepad, something like that. You could draw it out, or you can just use Notepad to write program, right? So I'm going to log in. I mean, you should be able to sign in, with your account, email account, and they should give you a free access for just limited resources you can use. All right, so after you sign in, you can start your free trial. Like it's going to have limited documents. Like now, let's look at this one. All right. So this is an example of the system for students to register for courses. But I want you to focus on, I just said, right? The first row is going to be class name. I make a student class, correct? And the second row is going to be the attributes, correct? Like attribute of student. Student is an object in this case, right? Name, email, username, password, date of birth, courses. So you tell me now, I want to build the online banking system, right? So what should be the UML diagram for everybody? So I'm going to scroll to the bottom. I have an empty blank UML diagram here. You could, when you first start Lucidchart, you could just drag and drop the tools, see UML diagram like that, then you get an empty blank UML diagram. So that's why I just recommend to use the program, right? So you said user, right? Is an object, correct? So this could be user, correct? That's the class name user. And we're going to do class in Java, we capitalize it, right? The U. Now, tell me what should be the second row. Yes, it's the attributes according to the class diagram structure. Name. Now, in Java, when you declare a name, you should give what? Can you just say name? Type. So now UML diagram, we put the name and then we do colon and then we do type string. Like Java is capitalized S, right? String is a class. That's how you draw the UML diagram. Now, in Java, you guys know this concept we call modifiers. So what is a modifier? Can you give me like the keywords for Java modifiers? No, getter and setters, those are the methods. So when we talk about operations in UML diagram, right? Those are the methods. So it's going to come on the third row. Okay. So we're not there yet. So we talk about modifiers. So what is modifiers again? Yes, public, private. Like that you modify the class, right? I didn't say you're wrong. You were saying it, but I just try to say, can you give me the word? Right? Now you said public private, which is correct, right? So you see we say public class, so it's modify the class to be public, right? That's why we call modifier, right? So what does it mean public class? Remember object use object, object use object, right? To make another object, right? So if one object is private, then another object cannot use that object. So you will never see private class because we build a class to make sure we can reuse it. Like if you build an object like in the real world, you make it private, it's technically nobody can even see that object is existing. It's just that sense. Make sense? You build something, you want to show it at least to public, even not allowed to use, right? Make sense? That's something existing. You build an object, you build new things, right? And you just, if it's private, then nobody really knows it's existing. So you commonly see public class. Now, modifiers also going to apply to the attributes and the operations, which we call methods in Java too. Because you guys see, you say public class, hello world, and then you say public static void main, which is the operation, which is the main method, right? So now we talk about the attribute first. Should the attributes be public or private? We talk about attributes. Remember, we talk about second row is attributes, third row is the operation, which is the methods. We're not getting to the third row yet, right?
Can it be both? Can it like just depend on what the attribute is specifically? Like can you have public and private attributes in an object?
Now, let's look at what is the attributes in Java code first. Then some of you may understand this more. So for example, I'm going to create a new project. Okay, we're going to say banking system. Creating a new class. So we're building a new class. Remember that UML diagram represents the class, right? So I'm going to make a user class, right? Because we just agree with that, right? Now, I'm talking about the modifier here, right? Should it be private or public? And you said string. Did we say name? Yeah, name, right? So in Java, it's like that, correct? So this is called attributes. It's not even a method yet. The question is, should this be private or public? And why?
Private. Because you want to hide certain implementation details from the user. Right?
Okay.
Sounds really high tech.
Okay. Think about an object again. The car engine. Is if I create a class, pretty much class engine, right? Represented by programming, right? And like engine has the attributes, right? Now, if I make the attributes private, like when you actually drive a car, do you really concerns about how the car run? you really think about accelerating down the accelerator, and the gas going to splash into the engine, and then the spark plug start to fire, and then you get all the power out and push the car forward. Do you really think that details? Right? So you actually see that when you sit in a car, you actually just step on that pedal, and the output is just moving the car from point A to point B, because it's being hidden, right? So it's being hidden. So that's why that's the concept of we try to make things encapsulated, mean encapsulate as much as we could. Only let the user access to the like pedal, right, and steering wheels. That's it. You don't want to exploit everything. Make sense? Make it simple. So that's why this is called encapsulation concept. So we want to, it could be public, but we try to make all the private, right? To encapsulate that. Like try to encapsulate as much as you could and let the user operate through it, through the methods in this case, all right? So that's why we want it to be private. Now, come back to the UML diagram. You see that they have plus and minus, right? So plus represent public. So minus represent private. Make sense? Okay, so the user, what else you want to add to this user? What are the attributes? Okay, password. Should it be private? Okay. String? Hmm? You say account? I'm sorry, you just, or char? The characters for which one? But when you say characters, it's going to be a one letter. A stream of characters becomes string, right? The sequence of characters. When you say character, it's only one. Okay. All right, so I guess you're happy with just name and password. We just talk about object user. All right, she started to talk about account. She talked about different object now. See that? If you try to mix all the attributes in one object, because user itself doesn't have. If you think account is the one, right, and user has the account, right? User is the object. User like a person itself, like you actually didn't born with the money in your hand. Money is another object. Make sense? Right, then we talk about relationships. That's why we have the arrows relationship going on later. Like this example said, we have student, we have course, right? And we talk about address. So let's talk about relationship now. Associations, relationships between classes. So that's why when we want to build system, we have to see relationships between objects, right? Association represents static relationships between classes. Place association names above, on or below the association line. Use a field arrow to indicate the direction of the relationship with the arrow. Place rows near the end of an association. Rows represent the way the two classes see each other. And if you start to look at multiplicity, notations near the end of an association, like 1, this is many, so one-to-many relationships. For example, one company will have one or more employees. So the company could be a class, right? And employee is another class. Relationship between the company to employees can be one company can have many employees. And you start to see this is the indicator like 0. Could be you can have no employee at all, but in that case, you're not going to be a company yet. So that's why it should be 1 instead of 0. At least 1, right? Like 0, 1, 1 only, you can do one-to-one relationship. Like one company have one CEO, something like that, right?
So if we know like a company has at least one employee, but they could have more than you do, one asterisk.
Asterisks represent any amount, right? Correct. 1 or more, right? And you can specify like n, where n greater than 1, and so on. You can press a constraint inside the curly braces. Now, let's look at composition and aggregation. Composition is a special type of aggregation. Like composes of, right? So it said composition is a special type of aggregation that denotes a strong ownership between class A and class B. Okay, we said the class A as the whole class and the class B as the part of the class B. And we use a diamond was filled with the black color. Okay, so they use a hollow diamond to represent a simple aggregation relationship in which the whole class play a more important role than the part class. You see, if you do filled diamond, it's represent composition. If you do like without the filled diamond, it's represent aggregation. Now, let's get a better, this is just explain what it is. We want an example. Okay. So I think let's look at your textbook. They have a good example about composition and aggregation. Now let's think about what is a good example for composition. Composition. What is a good example for composition?
Like what object is composed of? Is that?
Yeah, like object composes of other objects, right?
Yeah.
But composition is type of relationships of that object.
Yeah.
So composition would be like if most or not everything, if not everything, relates is associated with the two classes, but an aggregation would just be like one part.
Okay, let's look at this one. So we said student, course, and faculty, right? And we have indicators too. We just explained about it and direction. We see the question is student. Student has the attributes like name, right? Courses also have the attribute like course name, card credit hours, right? Student relationship to course should be student taking a course, right? Into this take as an action. And let's look at the faculty, right? Faculty teach the course, right? And we see one course. Let's look at student first. Student can have many courses, correct? Student can take many courses. And one course should have one faculty, right? And faculty can teach 0, no courses, or 3 courses, right? Or more, but not more than 3, right? Student, like courses should have at least 5 students, and the max is 60 students. All right, so let's look at now. We try to implement this. We create class name public class student, public class course, and public class faculty. Now let's think relationship that Emma was asking earlier, right? Student has the attributes. You see, student use courses because courses is the attribute of the student, right? And this is student can have many courses, so it's going to be an array of courses that we call course list. And the type of array is an object, array of object, which is course, right? And now when student want to add the course, we should have the operations called add course. And the parameter is going to be passing the course that student tried to add. Now let's look at how about the faculty object. Same thing, just like student, right? Because student can have more than one courses, then array of courses, and also add course to faculty, right? How about the course itself? The course itself should have student and the faculty. And then we have the array of student because we can have more than one student and only one faculty, so just faculty. And then we have the methods. Course can add the student and can set the faculty. So that's how we implementing it. Now we were talking about aggregation and composition. Again, aggregation is a special form of association that represents an ownership relationship between two objects. You may heard about has a relationship. So that is the aggregation model. An object can be owned by several and aggregating objects. If an object is exclusively owned by an aggregating object, the relationship between the object and its aggregating object is referred to as composition. For example, a student has a name. Is a composition relationship between a student class and a name class. Whereas a student has an address is an aggregation relationship between the student class and the address class. Again, student has a name is called composition. Student has an address is called aggregation. You can look at that way, like since address can be shared among other students, that's why we call aggregations. And again, the empty diamond is for aggregation, right? And filled diamond is for composition. Like this, in this case, right? Student composed with the name, student aggregates with the address, right? Because address can have one or more than one student. So let's look at this one. So we said it can be referred to itself too. Like a person is a class and supervisor. Supervisor is also a person, right? So that's why this is like persons. This is called what? Aggregating with one supervisor. I mean, the supervisor can have more person, but this in this case just refer to itself because it's a person, since supervisor is a person. Like a person may have a supervisor. Yeah, like this one, right? Can have several supervisors. Right, a person can have several supervisors.
would it
Yes.
still qualify as a composition if they're only at the moment only heard one person, or would it be classified as an aggregation since they could be heard more people later on?
So it depends on your design. Like now we said the rule is we can have multiples, so it's going to be aggregating. All right, so we good with the concept of relationships. Now, let's look at, we just talked about composition and aggregations. So let's look at this one. We just talked about what type of relationships when we talk about aggregating and composition as a, right? You hear another one, is a. So when we talk about is a, this is called a generalization or inheritance. So we may heard about inheritance, right? Another name for it is generalization. It means relationship between classes is a relationship. Now when we say is a, Emma has a car. So that is has a relationship. Emma is a car? No, Emma is not a car. So that's not inheritance or generalization, right? Okay. What is inheritance?
So that'd be like inheriting something that's already been like defined. So like for instance, like if you had two different types of cars, say a Honda and a Ford or something,
Mm-hmm.
they're both gonna have steering wheels of some kind. So they inherit like a steering wheel class or an object. It's basically like the same sort of mechanisms of a steering wheel would be present in both. So they could inherit like steering wheel. That example.
So if you look at Emma, Emma inherited from her mother. So her mother is the parent on the top, right? And then Emma is just at the bottom. Now, if Emma has siblings, so it's going to be Emma, do you have brothers or sisters? Then Emma gonna see another big brothers or big sisters name, right? So what are their name?
Oh, Allie, Andy, and Susie.
Okay, so that means the class is gonna look like so. This is gonna be Emma, mom, correct? And then we're gonna have three more other UML diagrams, right? That inherited from that. And this is Emma. We just use the same concept that we do uppercase first letter. And then you say Ali? Ali, like that? Or Ali, right? Ali. And another Andy. and this is the parent. And then we have to draw the relationships. And this type of relationship, we use the open arrow. We call inheritance. Okay. And this is exactly how you design object-oriented programming. I think this is the error we can pick, right? And let's just try to make it center. There you go. Take list like that, or you can just connect the dotted line, right? And these are the composition, aggregation, setup, relationship. All right, so now I just put it this way. Any questions on inheritance? Okay. This is some of the example. Let's go back to the beginning. They have one. All right, so let's look at let's try to read this a little bit. So this is a login. This is a database server. So we have a login class, and this login has check login as the operations start session, add cookies, right? And we have another class called after login, who is logout. And we have another class called the domain manager or group manager, like add domain, edit domain, delete domain, sort domain, create group, delete group, add users, edit user, delete user, change password, domain explorer. So they're just separate into different classes to handle different things. And this is pretty much just an interface to the user with a form, input username and password when you log in. So once you log in, it's going to the login. This is the server side. And it's going to check against the database and get the result after login. Right. And then it's just communicate back to the domain and respond to the users. I mean, this is just just an overview of an example of putting classes together, and they all have their own object or their operations, right? That makes sense? All right. So now we understand the concept of objects, right? A little bit in the term of we going to represent an object form an instance of a class which he mentioned earlier, right? He said an instant. Someone said instance, if you remember that, right? You did.
Yeah, you did, but I said later.
Right. So let's look at that term then. All right, so we build a user UML diagram. We said there are two attributes for now, name and password. We can add more. What are the operations for the user?
Oh, login box.
If you say login, should login belongs to user, or should login become separate class?
It should become a separate class because you're pulling everything together.
Right. So login should not be here, right?
No. But I was talking about the little. Oh wait, you're right. That also is a class.
We talk about the methods here, right? What should be the method for the user? Like user be able to change their name and password. So those should be the method. When you create a user, how you going to create a user with name and password? They should have the constructor. So the constructor is to initialize when the first object created, right? So that's why we call constructor. And there should be what public. Then it should be plus, like if you talk about constructor is the user. Now, what should be, methods should have parameters. And what should be the parameter for the user constructor? Name, which is type string, and password, which is type string. So that's one constructor. And now, constructor is when you create a user. But what happens if I want to change the name of the username, change the name of the password? Then I should have setters, right? Set name, meaning you provide a new name, right, to the parameter, right? That's what we call setters. Or we call mutator. And set password. So you have password. Pretty much you pass in a new password to the parameter, right, to set. Now, if I want to know what is the user password or the username, how do I get? That's why I have to get the method to get it. Get name, right? And then another method, right? Get password, and we call accessors. Like you access to get the data. Okay, do you want someone to get your password? Or actually the system login try to get the password of the user where you check against. Actually, you want to get the password to check because password belongs to object. Just like I want to get your social security number, then I can verify it is you, right? Okay, and we talk about it's encrypted or what, then that's another story, right? Then you should have the get password as it's public because we're gonna have another class called login. If it's private, then that class cannot get the password from the user to check. So it has to be password, like public. So we're not getting to that example of private yet. So the private method is the only method that used inside that class. Like, for example, you want to maybe calculate let's say if the user have the height and then you want to get the height. Get height should be public. But I want to get a height maybe in the metric systems returns in centimeters always. Then I could create a private method to call calculate the height in centimeters. I would get height just call calculate height. Then that should be private because we don't want it to share. Like we don't want other to just say user dot calculate the height. It doesn't make sense. Like that could be one example. Or could be a good example, the encrypt password. Like it could be a private method to do password encryption inside the user. And it's gonna be private. And then whenever you set the password, you just call that to encrypt every time. And then it's stored as encrypted. And that private method, you don't want anyone to access to get a key or whatever, right? Encrypt key is in there. That's another example, a good one. Right. Anything else? And it's very common to have two string. So two string pretty much just returns all information about the user, like all the attributes. Now, the method itself should have type, so that's why I use colon, like toString returns string, get password returns string, right? The method itself has the type, so we have to do that way, right? Set password void type, because it's not returned, right? Void user constructor doesn't have the type. So that's how you start to draw the UML diagram. When you design a system, you don't implement. You going to design the diagram, UML diagram first. It's easier to change from here, right? And then you don't have to worry about your coding, errors, syntax, how to use it. You only worry about the system, like what I needed, right?
Someone say something.
So now we gotta build an account, right? So we need another UML diagram, right? And we gotta say, okay, this is the account. Now we have to think about what are the attributes for the account. See, this type of thing always come from the business logic, right? Or the requirements when someone asks you to implement it, right? Like in a real world account should have account name, account number,
Name of, just the name of the person, or the number, right?
account could be the name of the person or the name of the organization.
Yeah. The bank name,
What should be account number?
the type, you mean type?
Yeah, type.
Number.
Huh?
Number.
Hmm.
They always tell them
Big,
big number, big.
big.
Big and small.
They have big decimal, big integer. I think they call. If you look at,
There's no decimal points.
they call big. I think they have big decimal. They have big integer, big decimal, big integer. Can be used to represent integers or decimal number of any size and precision. Because if you use int, what's the size of int? We talked about that, right?
No.
Yes. We review the primitive data type, chapter 2,
So, just the
32 bits. 2 to the 32, that's the size that you can represent. 2 to the 6, 2 to the 31. And then minus, actually, minus 1. And then 2 to the negative 2 to the 31, right? That's range. That's what I tried to say. Because it's 32 bits, so it's length between minus 231 to 231 minus 1. Because 0, that's why we subtract 1. That's the range that you can represent. Which, hopefully, I mean, it should be enough if we are not a worldwide banking. But if you're worldwide banking, then it's not enough because we cannot support billion of users, billion of accounts. So that's why, yeah, it's not bad idea to how would Java answer this when we try to represent something without the limits, which is the numbers, right? Which is the infinite. So that's why they just make another class to represent the number. Big integer is for the whole number. Big decimal is for the number with the decimal points. Now, should we use big integer or big decimal? Right, because the account should not have decimal, right? Like this is what big decimal. For a lot of numbers that come after decimal point, which is most likely used in scientific calculations. All right, so now you see that making a system is not easy, right? You think it's easy? Huh? It's not easy, huh? You have to think about many things, right? That you have to involve with. Like, think about if you don't know, you put integer right there. It's gonna be working until one day the account just go over that limit. Right? Correct? So that's why we need to do the test, right, in your program too. All right, so account type, right? Could be saving, checking. It could be enum too, you know, right? You guys know enum?
Email.
Enum, E-N-U-M. Enum is when you want to create your own type that you don't see on a primitive type, or Java doesn't provide any type. You use enum to create your own type, like Monday, Tuesday, or January, February, March until December. You could just create your own type using enum. But we're not focused on that. Let's come back here. So let's say we're gonna say this is enough for now. So what should be the operations or the methods? Same thing, the constructor. And this is how you draw the UML diagram, right, based on the rules. Variables name come first, followed by the type. So we say account type and string. So let me use same, no spaces. So that is the constructor. Same thing, we want to get, we want to have setter and getters, or accessors and mutators and accessors. Set account name, and this is based on the naming convention. You don't use spaces, capitalize between the word. This is called the camel case. So you pass in the account name, and this is void, right? Set account number. Now, do we want to how we want to create the account number? And this could be a private method too. Like instead of setting account number, it could be auto generated. So we remove that, and so we could create the account number. Now, would you let either user or admin or bankers, right, to change account number once it's created? Then you only need to have set account number. You only want get account number. Set account type, yeah. Because you still have to set either saving or checking.
Where would you put like a generated account number? Would you also put that here, or would that be like?
Right, we could just, let's say, let me do get, right, get account name, and this is a string. Get account type, this is going to be a string. Now how do we do the account number? We could get account number, which is big integer. We can have these are public, right? Public getters, right? And we could have another private, just called generate. All right, account number. Well, I always use AC, so account number. It's just going to return the big integer. Which, who's going to call that? Pretty much the constructor will call that, right, to set. And that is an example of private. Make sense? And then we have toString. So I just return the information about this account. And we normally want to have one thing we call like a counter to keep tracking how many accounts has been created. So, and this gonna be statics. We talk about that concept. So private. That's a UML diagram statics. I thought it's used the hashtag or for this, right? That's why I recall symbols. Underline it. Okay. Oh, hashtag is protected. The hashtag is the protected public private. So we underline when you refer to statics. So go back.
Why would like the current amount of accounts, like why would that be a static though? Because couldn't the amount of accounts change?
This is pretty much the count, right? And it's the underline. Now, why it has to be static? That's the question, right? What should be a type? It depends on what are you expecting to have. Yeah, expects to create. You see, it can be a challenge, right? Like, if you decide this for like Bank of America, probably it's gonna be a lot. Integer is not gonna be able to hold this. Okay, we gonna do long for now. Okay. Now, would it be why would it be static? That's the question, right? And anybody know? Static mean we're not gonna set, we're gonna get. And this is also a static method, get count. Can you repeat your idea again? Why this is gonna be static? All right. Let me explain it from the code then. So now we're going to build user and account. Okay. We have user private string password. So we get the constructor based on our UML diagram, right? So now once we get the UML diagram, this part should be very easy. We just follow it, right? Because it's pretty much just represent a class. We just need to have the right syntax. Right, private, public, get and setters. We got that. So lastly, it's going to be toString, right? And this is the reason why we have the auto-generated code here, because it's very common to build this type of, we call an object, right? Now, the class itself is not an object, right? This is just a class. When you instantiate it, that's an object of the class, right? The class itself, you can look at it as like template, right? Now we create another class, which is the account. It looks like it's faster to write a code than writing UML diagram. Right? Because the IntelliJ, I mean, had the tools that make it faster. Account name, account number. String, account type. You see, we don't have to think anymore because we've been thinking already when we're building it. Count one. So that's why being a junior programmer, you need to just know how to read. You're not required to think. Is that true? Not really, but you don't have to think that advanced into building the system. The architect is responsible for that, senior and architect. Long count. And we said this is going to be static, right? All right, so now I think we can create the constructors. So we don't need an account number, only these two. So what else? The get and setters for them, except the account number. We take it out, but we're going to change it to private. We said we call generate account number. And this will return big integer. And now we have to implement how we want to generate in here. We just need to, I put a comment, implement the logic to generate. Okay, for now, I pretty much just going to create a new equals to new big integer and just give the default value. Okay. 0. and then I can return. So the logic for this pretty much not allow duplicate, right? And just say the length, and pretty much just normally they're gonna have the code like the branch city where you create and things like that, right? Where you open your bank account and type account type. So those are the business logic. So are we done? We're done with account and user, correct? Oh, toString. So we need toString. All right, and we don't need set count because we always increment. Now we're not done for the account. We need to do count plus plus here. Whenever you create the account, you keep tracking on how many accounts, right? So that's count plus plus in here. Do you see the difference why statics and like account is static, like account number is non-static? Yeah, ma? Do you see the difference?
Yeah.
What's the difference?
The account number, why the account number static? Or like what difference?
Account number is non-static, but why count is static?
Why account is static? Because well you want the other like parts of the program to be able to draw what the current count is. So if the count changes, they need to be able to pull from that account.
What happens if I do non-static? If I remove static out, what happens?
Well, what did it be like? Well, I guess it depends on like what you change it to.
Can I change it?
Or do you,
We said you change it to. Who changed it?
well, I mean, you have like a base number and
Okay, base number. Okay,
say like you created a variable or something. Like
you need to get 0.
Others who try it, others drawing from it. I mean, you can just change it suddenly, let it.
So I guess the question should be simple and the answer should be easy by the question is what happens if this is not static? When I call count, what do I get? 1. I create another account. Let's say Mike. Okay, let's create an account now. New. How you want to do this? You want to use unit test? Okay, let's use unit test. Test generate the account, right?
That's why just so basically it'd be the same thing, like its value into one, right? It might be like
So let's test the get count. All right, so I'm going to test the account test, right? So how do I test that? Pretty much just create an object. So now we said account is a class. It's not an object, right? We talk about object-oriented programming, right? So the object is this guy, right? When I say account, I refer to a class, which is like a template, right? Then whenever I create first account, second account, like I can say account, this account is a my account equals to new account, and then it's required me to call the constructor that require me to provide the account name and account type. I missed one thing, I missed the balance. Right, that's the whole point, right? Let's add that real quick. At least we should have some money in here. What's the type? Double. Actually, it's recommended to use big decimal. Okay. And now I need to put it right here. Private big decimal balance. We can have set balance, get balance, right? Just deposit, right? Set balance. All right, let's generate that after this. Okay, we have get and set. All right, now constructor, we have to modify constructor a little bit to have big decimal balance. This dot balance equals to the balance. All right, so we have to create a new amount, new big decimal. Okay, 1000. Maybe Emma is having money more than this. Okay, 1 million. Is that true, Emma? I think that's good enough. All right, so account type. Okay, it's for now I use string as a saving because if I use enum, let's see if I say enum, right? You could create a new enum account type. This one could be a public enum, right? And then you just give the type like saving, checking, something like that. And then you could refer to, instead of giving this as string, right? Right, you just say account type instead. See? See, but you have to fix all this. Like if I want to create my own type, then I can use enum. Okay. Right. And then this part I can just say account type dot. Right. Dot, and then I can select the type, which is probably that million should be in the saving, right, Emma? So I just select the saving type. Now in that case, like that's why when I designed, I was thinking about that already, but I didn't want to mention yet because we're not implementing it. Then account type here should be account type, right? And then you want to create the UML for account type. Because what should be an enum? Something that always going to stay the same. Saving, checking, right? Then you don't want to make a string because it could make it so difficult for you to refer all the time, refer to, or even typo can be, right? It can create a typo. Let me verify. I think it should be just the symbol class and attributes. And then we just type, say, enumeration at the top. The rest is the same. And account type, right? Oh. Copy and paste, create a problem here. It doesn't allow me to go to a new line, huh? Okay. It should go underneath it, but looks like I cannot put it underneath it. So and this one is going to be the saving and checking, right? Let's see, like that, right? Like underneath it, like that. And we don't have the method, so I'm going to remove that part. Maybe I should use, the problem is I'm not sure. I'm gonna leave it like that because it's fine to leave it like that for the method doesn't have a class. Okay, like the class that doesn't have the method and enum. Now you may see the symbols like relationships, like enum being used here, right? And then relationship should be, we gonna use dotted line. Let me get it as solid first. We gonna use this and pointing to this like that. That's the relationships uses, right? All right, so that's how you draw the UML diagram. Now come back. This is how we use it. Like Emma just has one object. Now I want to test to create another object, another account. So we have Laura. So how much money you have, Laura? Not that much. Okay, maybe 10,000. Now Laura said, "Why you give me just that much?" It's just an example. All right. So now the question is, get count. How do I access get count? How do I get how many accounts I have created? It is already decided as statics, right? How do I get the count? Account. Is that right? Is that right? Who agree with Laura? Let's raise your hand. Yeah, I make it as private. I make it as private. All right, and I try to access with another class. If Laura said that, you can't because it's private. It's going to be you see it say has private access. You see that? This is right. You cannot do that. That's the modifier private. We make it encapsulate.
So then what's the purpose of a private static variable? I mean, you can access it from inside the same class definition, right? Counter.
Please be detailed.
We could access to because if you want to create a statics, if you want to create a statics get count, then this count has to be static. Otherwise, you cannot. Right? Like statics method involved with statics attributes. And we try to then there's going to be a problem. Non-static field cannot be referenced from a static content. And we create private, then we have with access to the interface, like the pedal. Well, access later with the pedal. I give you the pedal to access. So how do I get a count? How do I get a count? Get count. Right? Get count. So is it true I can do this way? It looks like it's true. And this is called white first white. Don't I say Emma dot get count? Oh, by the way, this has to be lowercase for the instance, right? The object should name lowercase. That's the naming convention, right? locus object or the instance variables. This is called instance variables. Like normally you say int x, x is a variable, but in this case it's instance variable because it is an instance of an object, right? Instead of a class name account, which is an object, instead of a class or an object, right? So that's why I call instance variable. So now get count. Come back. Can I say Emma.get count? Emma? Can I say instead of account.get count? Can I say Emma.get count? Hmm? You don't think so? How about you, Lawler? Can I say Laura.get count? Laura said, why you use my name? You didn't say bad? All right, let's run. What do you think we're going to see? Is it 1 or 2 or something else? 2. Why is it 2? There's so many questions going on here. So let's go back to the first question. What? Why have to do account and get count, not get mother get count or Laura get count? Because static method should access as the static way. Static way means like math dot square root, math dot absolute. You never instantiate an object of math, right? You could theoretically you could, but you shouldn't. It should access in the manner of static way. Why? Now come back to why statics. So why? What was the question I said? Why is it 2, right? What was the question? Is that a question?
Mhm.
Why is it 2? When I create a count, it's invoke this constructor and increment this every time from 0. And how many times I do it? I did it twice, so this is 2. And the reason is 2 because it is statics. Okay, Emma, look at the one that's not static. Like maybe your balance.
You get different right? You're looking for your balance.
If I like set balance, I change your 1 million to 0. Okay. So let's try. Emma. So let's print out 2 string of Emma. So when you have 2 string, the good about it is you don't need to do .2 string. It's going to show the information about Emma account. Right, that's 2 string. Right, account name Emma, account number is null, we didn't create it yet, right? Account type saving, right? Oh, we have to add the balance too. So let's see, we can add the AC or the balance equals to like that, right? And for now, we could set the account number to the default first. Get generate, right? We use private right there. Okay. So let's say now I'm going to withdraw or set the amount. We could add the withdraw too. Like if I want to add withdraw to account, I just going to do, oops, sorry. So just type public withdraw, and then just pass the balance that you want to withdraw, right? And then this dot balance minus equals to balance, right? Oh, but this is not, this is big decimal. Can we do that like that for the big decimal? Nope. So subtract, right? Because you have to use the method because not primitive type, right? So now you have the new balance. All right, so let's test again. We said Emma withdraw, and then this is the big decimal, so we have to create a new amount. Maybe we just withdraw 500,000, and then we're going to print out after withdraw, right, to see the balance.
I would love to be here for the rest of the class, but I have to leave so I can attend the wedding and get ready for the ceremony. I'll see you guys next class. Thank you. Well, I'm the one getting married, so that's what happens. No, I'm not getting married. It's been 10 years.
All right, so let's see what happens, right? So we call withdraw. Now what we can do, we can do the toggle point. We could use the debugger, and then we can trace to it to see why is it not changing. So at this point, it showed information about in my account with 1 million. So we could do step into, so it's going to jump into the withdraw method. So it took 500,000. And say the balance is, the this dot balance is 1 million. The balance that we try to subtract is 500,000. It say here, right? So when I do step into, it's just exit already, but the balance still 1 million. So let's think about this concept then. Why is it still 1 million? Because big decimal. So when you subtract, method's supposed to return, right? I did not, right? I need to make, because it's object, right? After subtract, just return. I need to update the amount, right? There you go. So the balance is 500,000. Okay, Emma. I'm sorry, I want to use you guys as an example because you are the outstanding students, not the rest. No, I didn't mean to for the rest. You guys also outstanding. Okay. All right. So if you look at this, Emma, do you think your balance is going to affect lower balance? It shouldn't. Why? Because they are non-statics. Remember, if it's statics, when I do the count, it's affect. When affect means Emma get count and Laura get count give me the same thing. That's me affecting when they're statics. So if I make the balance statics, then everybody is going to have $1 million. Right? I mean, but that's the concept of statics, right? Okay, not all of them not going to be complaining, but when you withdraw 500,000, they all going to be complaining because it's affecting them. So that's why we cannot make statics. When now you understand when the attributes, like since it's the object has the attributes that belongs to its own object, right? Then those should be non-static attributes. Right? When static is pretty much just like the word says, it stay the same when other object update. The other object will get affected, right? To that static attributes, right? Good. Now, the relationship here, actually account and users, they're on its own. But the one who make relationship is it's gonna be another class, like maybe create account class. And create account is gonna use account and user. And that is just like aggregating or composition, just like student, course, and faculty, right? Like user account and right create account, right? Okay. So let's come back to are we supposed to be on chapter 9 or 10? 9, okay. So I explained pretty much combining 9 and 10 at the same time. So let's go back to review if any topic that we should cover. So now we understand what is class and what's object, right? So in this case, in this program, class is account, class is user, object is Emma and Laura, correct? And we explained how to use UML diagram, right? To describe, right? So we call OOP. OOP stands for Object-Oriented Programming. People just call OOP, right? Yeah, some people say that. This one is just try to show you the data fields, the methods, and the class, and this is the same, right? The data fields are we call the attributes, the constructors. Now, what we have one constructor that is taking no parameters. So this is called a default constructor. Normally, when you don't have any constructor created, this is going to be automatically created for you. But once you have your constructor created like that, it will never create it. So it's a good idea to add the default constructor too. Okay, we're gonna need that when we do inheritance. That's why we should want to add that. And it's fine if you don't want to initialize any value, you can just leave it empty like that. Or you could just make it like all 0 or null or some values to it. Like I said, you can leave it blank or you can just make a John Doe account. John, something like that, right? Just like we know it's going to be the default settings, something like that. Account type. Checking. Account number. Zero balance. Okay. Like if we call that object, like when we create account, it's going to be like pretty much just keep that default values. In this case, get count happen to print.
Oh, you didn't have.
I didn't do the plus plus right there, right? I have to add that too. So make sure all the constructor has to have the increment. And you can see with the statics, it's fine. They're all affected, right? But the non-statics, they also have their own balance. Okay. All right. And this is called constructors. Any question about constructors? Data field, methods. It's very common to have getter and setters. And this is the UML diagram to representing it. And this is just the UML notation for the objects. Once created. So the first row pretty much just the object name and object type as a class and the attributes values for each of them. This is pretty much just running the main method which I put in my unit test. This is just showing again in another class. So this is just give another example with the television class has a channel, the volume level on or off, right? And then they have constructor TV and the method turn on, turn off, set channel, set volume, channel up, channel down, volume up, volume down. So pretty much just start to add other method about television, just like we start to add withdraw, right, to be an operations of the account. And this is pretty much how they implement it. So, do we need a break?
Yeah.
All right, let's take a break. Then we come back.